Hello, welcome to the class for today. We are going to be looking at some area and cubic expansivity in this class for today. Remember, we have discussed heat energy. We've looked at temperature, conversion of temperatures. We have also looked at expansion and linear expansivity. So in this particular class, we'll be discussing area expansivity and cubic expansivity. Then we'll look at some relationship between the area expansivity, linear expansivity, and cubic expansivity. Then we'll also look at some calculations, okay, how to solve problems on area expansivity and cubic expansivity. Okay, so this is Normal Science Tutors Online. I remain notable Michael. If you have not subscribed to this channel, please click on the subscribe button. Also click on the notification button so that when we upload a new video, YouTube will notify you. Also, you can reach us via the WhatsApp number that is showing right on your screen. As I've always said, this is a physics class out of your normal classroom class. So this is bringing physics lecture direct to your very home, and we are treating the Nigeria curriculum of physics for SS1, SS2, and SS3. We are taking it gradually and stage by stage. So please watch all our videos that are in our playlist so that you see how we started from the beginning and how we are progressing gradually. Invite your friends to come and enjoy this video class that you are enjoying. Get your writing materials ready so that we can move straight to our class for today. You are welcome to this class. Okay, just as we discussed in linear expansivity, this is area expansivity, and we know that when a solid is heated, it expands in all directions, both in the length, the breadth, and in the height. So, which means that there will be an increase in the area of the solid and also increase in the volume of the solid. Okay, so the increase in area of a solid when it is heated is also known as area or superficial expansivity. So area expansivity of a solid is the increase in area per unit area per degree Kelvin increase in temperature. Now, if you remember when we treated the linear expansivity, the equations are almost the same. But in the case of area expansivity, now we're using A instead of L. When we treated linear expansivity, we use L. Okay, so if AO is equals to your original area and your A1 is equals to your final area, okay, so then this is your original area, okay, the original area. So we can actually write similar equation that we wrote when we did the linear expansivity. Okay, so increase in area is equals to A1 minus AO, that is final area minus original area. And we also said that change in temperature or increase in temperature is equals to final temperature minus initial temperature. That was what we did for linear expansivity. Okay, so we can actually write that increase in area is equals to the area expansivity represented by beta multiplied by original area times change in temperature. So assuming you are asked to find the final area of a body of an object, you can just rewrite this equation to be final area. It will be equals to AO Remember the way we wrote it for linear expansivity, 1 plus area expansivity times change in temperature. So depending on what you are asked to find, you can actually use this equation to find the new area of a solid. Okay, so this is the equation for area. All that I wrote here is what I've already written here. Okay, so everything here, you can put this in your notes. You can pause the video actually and make a note from this. That's why I try to put down, instead of just talking, I try to put all these informations down so that you can make your note from what you are learning. You can actually make a comprehensive physics note from what you are. So you can pause it, copy this in your notebook, and then you have a very comprehensive note. Okay, so this is area expansivity or superficial expansivity. Okay, so let's look at volume expansivity or cubic expansivity. So just as we did for area expansivity, that's what we also do here. The difference is that you are going to replace area with V. So if you follow through, you find out that they are exactly the same thing. V1 is initial final area volume, V is initial volume, this initial volume, this change in temperature, and that gives you this. So expansion or change in volume is equals to cubic expansivity multiplied by original volume and change in temperature. So in case you are finding a new volume, which is V1, the final volume, you just use this equation. And that is what we did for area and linear expansivity. So there is no ambiguity in what we have discussed so far. I think everything here is clear. Is that okay? So if you understand linear expansivity and area expansivity, it's just for you to remove area and put volume there, and then the equation comes out readily. The equations comes out the same and readily too. So now we are going to look at the relationship between area expansivity, cubic expansivity, and linear expansivity. Okay, so this has already been solved, and from calculations, the linear expansivity, area expansivity, and volume expansivity are related by these simple equations. So which means that area expansivity is twice linear expansivity, and cubic expansivity is thrice, or it is 3 times the linear expansivity. So please take note of all these equations because you are going to use them to solve some problems. I hope that is clear. Okay, so now I want to do some calculations, right? We'll do some calculations, but before we do those calculations, we just want to discuss briefly expansion in some other um, in liquid and glass in some other materials. So let's look at that one quickly. This just for your own further learning. Expansion in glasses. I mentioned this before that when hot water is poured into a glass, the glass will crack. And why this happens is because of the uneven expansion of the inner surface of the glass and then the outer surface. So because of this uneven expansion, the inner surface will expand more than the outside surface, and that is what will make the tumbler to crack, because glass is a poor conductor of heat. Okay, so this is just basically this explanation that is here. I want you to take note of that. So can you ask you in your examination, why is it that when hot water is poured into a glass tumbler, it will crack? And how can you prevent it? You can prevent it by putting a metal spoon on the glass, inside the glass, so that as you turn your hot water into the glass, the metal spoon will conduct the heat away, because know that metals are very good conductors of heat. So if you put a metal spoon inside your glass tumbler, it will not crack if you turn hot water on. But if there's no metal spoon, it will crack. Okay, it will crack. Okay, so that is it. Then expansion in liquids. Liquids like solids expand when heated, but liquid expansion differs from expansion in solids. When a liquid is heated, the level of the liquid will initially fall slightly and then rises steadily as more heat is applied. Why do you have this experience? The reason is that the glass will first expand. That is a container. The glass will first of all expand. before the liquid will start to expand. So the glass first expand faster than the liquid, hence the fall in level. Okay, so this, as I said, these are information that you need to know, right? These are concepts that you need to know. You need to know these concepts because sometimes it is not everything that you actually see in your physics textbooks. So most of this information that I'm giving out here, you might search the whole of your textbook, you will not see them. But I like to make sure that my students, I don't hide any information from them. Yeah, try to make sure that any information that they will need in their examination, I give it to them as it's supposed to be. Okay, so this is what happens when a liquid is heated. So what of water? When water is heated, what happens? Now, many liquid, as we said, when they are heated, they will expand. But for water, it behaves differently. When water is heated between 0 degree and 4 degrees, it contracts. As a result, there will be a decrease in volume and increase in density. So between 4 degree and 100 degrees centigrade, the water will now begin to expand uniformly like other liquids, which results in increase in volume and decrease in density. So this is how water actually behave, and I try to represent it in this simple curve. So assuming water, at -5 degrees, it is ice block. So as we are heating it, it will begin to expand. But when it gets to start to melt. But when it gets to 0 degree, it will contract. It will contract between 0 degree and 4 degree. Then as from 4 degrees centigrade, it will start to expand. Is that okay? So for other liquids, when cooled, they contract, but water will contract when cooled from any temperature until at 4 degrees centigrade, when it will now start to expand if cooled below that temperature. You know that now that ice, right, occupies more space than the liquid that is used to form it. Yes, ice occupies more space than the liquid that is used to form that particular ice. So does water expands when cooled from 4 degree to 0 degree, and also to lower temperatures. Hence, water has the least volume at 4 degrees centigrade and behaves anomalously between 4 degree and 0 degrees centigrade. So this is a question that I normally ask: between what temperature does water behave anomalously? Okay, so it is between 4 degrees centigrade and 0 degrees centigrade. And this behavior of water makes it possible for some marine life to survive in those areas where the water or the lake normally freezes during winter. In some countries, you have lakes that are frozen, but there are still fish surviving under it, and it is because of this behavior of water. This anomalous behavior of water makes ponds, lakes, and rivers to freeze from the top surface rather than from the bottom. And this now helps marine life to survive during all those winter season and all that, because water at 4 degrees centigrade is okay for marine life to survive, right? So this anomalous behavior of water is very, very important for the survival of marine life in those regions where lakes or ponds normally freeze to ice. Okay, so this is the anomalous expansion of water. So right away, guys, we have a question here that we need to solve to further deepen our understanding of what we have discussed so far. So this question says an iron cube has edge 50 centimeter long at 20 degrees centigrade. So take note of this question. Say iron cube. You know that a cube has the faces with the same length and breadth and height. I hope that is clear. A cube has the faces, the same length, the same height, the same breadth. All the faces are equal, all the sides are equal. So the question is that what will be the new surface area of a face when the temperature rises to 80 degrees centigrade? The volume at the same, the new volume at the same final temperature. Linear expansivity of ion is equals to this. Now we have been given all this, so we have to solve this problem. Now we said that area expansivity is equals to final area minus initial area all over initial area, original area times change in temperature. Okay, this is the equation we have. We also have that area expansivity is equals to 2 times linear expansivity. So take note of this equation so that let us now bring out these informations from the equation that is given to us. Okay, the area of a cube, the face of the cube is 15 centimeters. So area will be equals to length times breadth. Okay, so that should be 15 times 15, and that 15 times 15, you multiply it out, you are going to have 225 centimeter squared. All right, so this is the initial area AO, because the question says find the new surface area. Now the change in temperature is equal to 80 minus 20, which gives us 60 degrees centigrade. I hope that one is clear. Then we said that area expansivity is equals to 2 times linear expansivity, so it's equals to 2 times 12 raised to power 10 raised to power minus 6. Okay, so by the time you multiply this out, you are going to have 24 times 10 raised to power minus 6 per Kelvin. Okay, so we have gotten this now. So we said that for your new area is equals to AO is equals to initial area bracket 1 plus your area expansivity multiplied by change in temperature. So if you substitute now into this equation, you are going to have that your initial area is 225. I hope you take note of that. 225 all over 1 plus your change in temperature is 60 degrees multiplied by your area expansivity, which is 24 times 10 raised to the power minus 6. So if you work this out from your calculators, if you work this out, you are going to have that the new area will be 225.3 centimeters squared. 0.3 centimeters squared. This is what you are going to have. Just solve this, punch this out in your calculator, punch this out there, add, multiply 60 by this, then add 1 to it, then yeah, is that okay? Multiply 60 by this, add 1 to it, then multiply everything by this. Your answer will just come out readily. The answer will come out readily. So that is for that part of the equation. Then for this is for the part 1 of the equation. Okay, then for the part 2, for the part 2 of the equation, here we are going to find the volume of a face of the cube. So volume, which is initial volume, it will give us length times breadth times height. So if you multiply 15 times 15 times 15, work that out, you are going to have 3375 centimeter cube. So this is your VO that you have gotten, and the change in temperature is the same 60 degrees, so I'm not going to calculate that one again. Your cubic expansivity is equals to 3 times linear expansivity, so that will be 3 times 12 times 10 raised to power minus 6. Okay, so if you work that out too, you are going to have 36 times 10 raised to power minus 6 per Kelvin. So I haven't gotten this, you can just, the way we did for the area, you can do for it to get your new volume. So that your new volume will be equals to VO bracket 1 plus your volume expansivity times change in temperature. Okay, so that gives us your VO is 3375 bracket 1 plus your cubic expansivity times your change in temperature, which is 60. So work that out with your calculator. If you work that out with your calculator, you will have your new volume to be 3382.3 centimeter cube. Okay, so if you look at all these problems, you find out that they are not really that difficult. It's just for you to know what to apply when you want to solve problems on this. Is that okay? So we are going to go straight to your test your understanding. This is another question too before we go to your test your understanding. Okay, so I think this one should be direct. This one should be direct for you to solve. This one is solid metal cube of size 10 cm is heated from 10 degrees to 60 degrees. If the linear expansion of the metal is this, the linear expansivity is equals to 1.2. Calculate the increase in its volume. Calculate the increase in its volume. So this one is easy. So the same equation that we used just now is what we are still going to apply. That volume expansivity is equals to final volume minus initial volume all over initial volume times change in temperature. Okay, so from this one now, the volume, initial volume is 10 times 10 times 10, which gives us 1000 centimeter cube. 1000 centimeter cube. That's what you have here. That's for your VO, initial volume. Okay, then your change in temperature is equals to 60 minus 10 is equals to 50 degrees centigrade. You are giving your linear expansivity to be this, so your volume expansivity will be equals to 3 times linear expansivity times 10 raised to power minus 5. Okay, so this will give you your A volume of expansivity will be 3.6 times 10 raised to the power minus 5 per Kelvin. Okay, so we have gotten all these informations now. They said calculate the increase in its volume. Calculate the increase in its volume. So we are going to find the final volume. Then from there we can get the increase in volume. So from this equation, we said that V final volume, or V minus VO, is equals to cubic expansivity change in temperature times initial volume. So your final volume will be equals to VO brackets 1 plus cubic expansivity times change in temperature. Okay, so when you work all this out, put your initial volume is 1000 bracket 1 plus 3.6 times 10 to the power minus 5 multiplied by 50. If you work all this out with your calculator, you are going to have 1001.8, so centimeter cube. This is your new volume. So change the volume, which is V1 minus VO, which is equals to increase in volume, is equals to this one 1.8 minus the initial volume. If you subtract that, you are going to have 1.8. So 1.8 is the increase in volume for this. So just see how these problems are solved so that you can be able to solve your own. Check your textbooks, check your past questions and answers so that you can solve more problems. So I have your test, your understanding. Please solve this question. Solve this question. You can put your answer on the comment section or call me through the WhatsApp number I'm showing on your screen, so that we can, if you have any challenge, we'll discuss it together. Is that okay? So that is where we are ending our class for today. Thank you so much for your time. But before you go, please subscribe to our channel now. Click on the subscribe button, click on the notification, so that when we upload a new video, YouTube will notify you. Also invite your friends to come and join this channel. And if you are new, you are welcome to this channel. This is Nobleman Science Tutors Online. We are bringing physics direct to your doorsteps, and we are taking it from SS1 to SS3 of the Nigeria curriculum in physics. So welcome to this class, and please, you can reach us through the WhatsApp number that's showing on your screen. Right? You can call us, tell us any way that we can help you. We are here to support you so that you become better in your knowledge of physics. So thank you for your time. Hope to see you in our next class.